In this video, I'm going to go through forming a complex second order differential equation. So I know a few of my students struggle with this, so I thought I'd quickly make a video about it. So d squared x over dt squared, that can be written out as d over dt, lots of dx by dt. The reason we can write out like this is because in this format, the numerators would multiply to give d squared x, which is what we need, and the denominators would multiply to give dt squared. So what that means is we have to use implicit differentiation in this question. The reason for that is because everything of dx by dt is not written in terms of t. So, for example, when we differentiate minus 2x with respect to t, it will just be the normal differential of minus 2x, which is minus 2, but then you have to multiply onto it dx by dt, because again, it's not in terms of t. Similarly, when you differentiate 78y with respect to t, you have to first differentiate it normally, so it's 78, but then you multiply onto it this time dy by dt, because this variable y is not in terms of t. When you differentiate any constant with respect to t, it will just be 0. So we can write out d squared x over dt squared by this expression here. So let's start by writing that out. Minus 2 dx by dt plus 78 lots of dy by dt. When it comes to the next term now, we can write that out as 80 dx by dt. And I'm just going to write this out here. You guys might be thinking, can't I just substitute in now? But you can, but yeah, let's take this step by step. So we see that there's, sorry, I don't know why I wrote an x there, it's supposed to be multiplication. There's two terms with dx by dt, so we can collect like terms, and we can combine them together to get you 78 lots of dx by dt, and then plus 78 lots of dy by dt. Now when it comes to showing that all of this is equal to 78k, what you want to do is replace dx by dt with this whole expression here. So we have 78 lots of everything that dx by dt is equal to, minus 2x plus 78y plus k, and then you add on to that 78 lots of dy by dt. So let's do that. 78 lots of 2x minus 78y. And when you expand out the brackets and collect like terms, you should get that ends up at 78k. So let's take this step by step. 78 times minus 2x is minus 156x. 78 times 78y is 6084y. Okay, 78 times k is plus 78k. 78 times 2x, I'm just going to very quickly double check that I'm doing everything correct here. So plus dx by dt. You guys can skip ahead a few seconds if you'd like. Yeah, okay. Moving on, 78 times minus 78y now is going to be equal to minus 6084y. Now, when we collect like terms here, what we'll see is that, oh, I feel like I missed out a term. And I have. So we got to 78 times k, 78k. And then 78 times 2x is plus 156x. There you go. 78 times minus 78y is equal to minus 6084y. And if we now collect like terms, what we'll see is that the minus 156x cancels out with the plus 156x. The plus 6084y cancels out with the minus 6084y, leaving you with just 78k. And just like that, we've proved this equation is true, and now we can go on to solve this for second order differential equations. I'll make a separate video about that part of the question, but I just wanted to make it very quick and simple for those that struggle only with this part of the question. Be sure to like the video if it helped and subscribe. I'd appreciate it a lot. Thanks for watching. I hope this video helped. If you have any tutoring inquiries, be sure to visit my website www.excellineducation.co.uk. It's on the first link in the description too.